Okay, so chapter 9 deals mainly with something called polynomials. 9.1 specifically is on adding and subtracting polynomials. But first, it's going to be helpful for us just for this entire chapter and here on out in mathematics really is to break down some of this new terminology. So a polynomial is just an expression that consists of the sum of terms a times x to the kth power. So it might seem a little confusing, but here's what a polynomial might look like, where you have something like 2x to the third power plus 5x to the second power minus 4x plus 7. Each of these terms has a coefficient. Here it's a 2. Then it has the x value, and then it has an exponent, so a k. Even the 7 would be 7 times x to the 0th power, because anything raised to the 0th power is just 1. So a polynomial is just an expression that consists of a bunch of these little terms that look something like a times x to the kth power. Standard form for a polynomial is just writing the polynomial out in an order in which the exponents are in a decreasing order. So here at our example again, we had x to the third, then x squared, then x, and then we just had our constant term here. Notice the coefficient, with the value of the coefficient, the 2, the 5, the negative 4, the 7, doesn't matter for standard form. It's all about the exponent. Which one has the highest power? Put that first. And then the next highest power, put that next. Next is just a way to break down a couple different looking polynomials. So a monomial is just a polynomial with one term, so something like 7x squared. Binomial, the prefix bi would imply 2. So that's a polynomial with exactly 2 terms, something like 2x cubed minus 4x. Trinomial, think triangle, that would mean a polynomial with exactly 3 terms. So 2x cubed minus 4x plus 7 is a trinomial. So 1 is a monomial, 2 would be binomial, 3 terms would be a trinomial. So if we want to know what the degree of a polynomial is, that's just simply the largest degree of the polynomial's term. So if it's written in standard form, it's just the degree of the first term. So looking back here, the degree of this polynomial is 3. The degree of this polynomial is also 3. Here the degree of this polynomial is just 2. The leading coefficient is the coefficient of the term with the highest degree, so it's the number out in front of the highest degreed x or variable that you have. There's also a note here, to be a polynomial, exponents all have to be whole numbers. You can't have negative exponents, or you can't have exponents that are fractions. So just looking down at this table, if you just are told the expression is 9, that is technically a polynomial. It's a monomial, a 0-degree monomial, in fact. 2x squared plus x minus 5, yep, that's a polynomial. It's a second-degree trinomial. See, the degree is 2, there's 3 terms, so it's a trinomial. Here we have 6n to the 4th minus 8 to the nth power, and that's not a polynomial because that exponent here is an unknown value, so this is not technically a polynomial, even though it might look like it. Similarly, here we have n raised to the negative second power minus 3. That's not a polynomial because, looking back up here, the exponents have to be whole numbers. Negative 2 is not a whole number, that's an integer. So let's look at this a little bit further. If we just are given the polynomial 6, that degree is 0. That's like 6 times x to the 0th power. Leading coefficient here is 6. How many terms is this? Just 1. The degree on this polynomial is just that first degree if it's written in standard form, so 2, it's the highest degree. Leading coefficient, there's a negative x squared. So what that negative means is it's negative 1 times x squared. So we just have negative 1. Number of terms, 1, 2, 3. Just 3 terms. Degree of this next polynomial is just 1. Leading coefficient is 3. And the number of terms is 2. So I'm hoping now you have an idea of how to do this. Go ahead and pause the video if you want. Try these next few. See if you can get them right. But I'm going to continue on right now. The degree here, negative 2x, is just 1. Leading coefficient is negative 2. How many terms? Just 1. Degree here, the highest degree is 3. Leading coefficient is 4 because you have a 4 right in front of that x cubed. Remember, it does not matter that 4 is less than 8. Don't think like that. Just think what's the coefficient in front of the highest degreed term. And number of terms is just 2. Degree on this next one is 4. Leading coefficient's 2. Number of terms is just 3 again. It's a trinomial. So anytime you see a 1, that's a monomial. 3 would be a trinomial. 2 would be a binomial. I didn't take the time to write that in, but that's there. So let's get into the nitty-gritty of 9.1, adding and subtracting like terms. So we have two main methods to do this. The first is the horizontal method. And horizontal, like you think you're going to add horizontally. So just thinking back to being in elementary school, perhaps, you could add 4 plus 4 like this. You could say 4 plus 4 equals 8. Or you could do 4, well, it's getting sloppy, plus 4 equals 8. Both ways work perfectly fine. It's the same idea here, where you can add horizontally or you can add vertically, depending on which is easier for you. The trick here is you can only add like terms. So you can only add 5x cubed to anything else that has an x cubed term. So here. That's why in our horizontal group we say 5x cubed minus x cubed. With our x squareds, you can only add x squareds to each other. So we have 2x squared plus 3x squared plus 4x squared. So we're going to put that here. We can only add our x pieces. You have negative x plus negative 4x plus negative 8x. You're only adding those like terms. And then you're only going to add your constant term, 7 plus 7, and then there's no constant term in our last piece that we're adding. So now from here we just simplify all of this. 5x cubed minus x cubed is just 4x cubed. 2x squared plus 3x squared plus 4x squared, you can think 2 plus 3 plus 4, that's just 9x squared. Negative x minus 4x minus 8x is minus 13x plus 7 plus 14. So notice once we're here, we can't do any more adding. You cannot add 9x squared plus 4x cubed. It's going to be tempting, but you can only add things that are like termed. You might find the vertical method to be easier to avoid silly mistakes. If you line everything up vertically, you can just add vertically. So that way you're not getting confused what can I add to what. You're only going to add your constant terms together. 7 plus 7, you're just going to add straight down 14. Then you have negative x minus 4x minus 8x. That's still going to be negative 13x. Now you have 2x squared plus 3x squared plus 4x squared. That's just 9x squared. And then you have 5x cubed plus this would be 0 plus negative x cubed is just 4x cubed. So notice you get the same result regardless of the method that you want to use. Just remember, you cannot add something like you can't add your 2x squared and your negative 4x. You can only add like termed pieces. So go ahead, if you have a piece of paper, go ahead and try this next one on your own. You can pause the video if you wish. Okay, so now I'm going to go through this one. We're going to add vertically in this case. So we have negative 2x to the 4th plus 5x squared minus x plus 8. Now we're subtracting all of these pieces. Now we had negative 2x to the 4th and 5x squared. I didn't really leave much space, but I'm just going to squeeze it in here. Negative 2x cubed plus 3x minus 4. Now the biggest trick here is to remember that we're subtracting everything. So we have negative 2x to the fourth minus 0x to the fourth. So that's still negative 2x to the fourth. Now we don't have an x cubed term on top, and we're subtracting a negative 2x cubed. So that's like 0 minus negative 2x cubed. So we're adding 2x cubed. Remember, subtracting a negative, chop, chop, make that a positive, so plus 2x cubed. Now we have 5x squared minus, we don't have an x squared term, so just 5x squared minus 0, so plus 5x squared. Here we have negative x minus 3x, that's minus 4x. Be careful, now we have 8 minus negative 4. That's not going to be 4. 8 minus a negative is like 8 plus 4, so that's 12. So this sum is actually negative 2x to the fourth plus 2x cubed plus 5x squared minus 4x plus 12. Let's do our horizontal method. We can only add like terms, or subtract in this case. We have x squared minus 8 minus the quantity 7x plus 4x squared. So you notice we have an x squared piece here and an x squared piece here. So we're going to take x squared plus or minus positive 4x squared. Then we have minus 8. Don't have any more constant terms over here, so we're left with just minus 7x. Combine our like terms. X squared minus 4x squared is negative 3x squared. I'm just going to rearrange this, put it in standard form, not changing the 7x, not going to change the 8, just going to rearrange. So our sum is negative 3x squared minus 7x minus 8. And if you're still curious, why can't we combine things like negative 2x cubed and 5x squared? Well, think back to a problem like this. If you have x plus, this is just a side note, x plus 2 plus 2x equals 5. Well, you'd solve this by first combining like terms, right? But when you combine your like terms, you're not going to say x plus 2x, and you're not going to get 5x. You're going to get 3x plus 2 equals 5, and then you could go on and solve from there. Get x equals 1. But you're using the same principle as you did here, where, oh, I can only add the x and the 2x to make 3x. That's all it is. You're using that same principle, only now you have terms that look like x squared and terms that look like x cubed or x to the fourth. You can only add like terms. So that about wraps it up for 9.1.